Can you see it? You see it? So what's this red trace tell me about that?
There it is.
That's awesome, we caught it live. I'm glad we didn't shut that off. All right, in the last segment, we energized the coil. In this one, we are going to do the ramp, the current ramp test. Hopefully, we can recreate the fault that we saw, which was a missing ramp, and then I'll show you how to troubleshoot that. Even if we can't, this next part is important in knowing how to do this. So really, that's our main focus, is how to perform a coil current ramp test, and in this case, on multiple coils in a common location. And then how to figure out which one's which, okay? Scope I'm using, I've had this screen up the whole time, is the Pico, right? And this is the 4425 model for anyone that is interested in the one I'm using. The first thing that I'm going to do is I'm going to use an inductive low amp probe, okay? And that's just going to read the current flow on either the power or ground, which we talked about in part 1 on this ignition coil. Questions so far in the connections? Okay, as far as the amp probe, does it matter polarity?
No.
It doesn't. We can invert it. Knowing which one my power feed is, though, I know the direction of flow. Where is my arrow at on this? Oh, it's inside. So direction of current flow, conventional theory, the arrow points us toward, right? A key with the amp probe is if the jaws of the amp clamp are not all the way around the wire, you're going to have an issue. It's not going to read right, okay? We want to zero that amp probe too once we get it into place. The reason that my screen looks like that right now is it is on an auto scale, and what the auto scale will do is go on the lowest millivolt reading to give you a good picture. And you see it's only a 100 millivolt screen. So don't worry about that. We have to tell our scope what we're using, just so we don't have to do our math. Oh, and by the way, I was reminded of this yesterday. A lot of the pictures I have in my book for you guys that have amperage patterns coming up in this ignition system and in the fuel system, you'll notice it's a voltage pattern. I want you guys to remember that I am picking, I don't know why I did those pictures that way. It was stupid that I did. Trying to do too many things at once. Hold on one second. 60 amp current clamp in the 20 amp mode, that's the one I want. Okay? And then as far as an ignition coil goes, the hard part about scope tests when you're new to this is what do you set it to? We have a lot of questions on what do you set it to. That'll come with time. What we set it to has to do with experience and knowing what you're working on and how many amps they typically draw. I taught you guys about injectors this morning. A saturated switch injector is how many amps? 1 amp. Peak and hold is what? 4 in 1. So if I'm looking at a peak and hold injector, I'm not going to set my scope up to less than 5 amps. Agree? I want to see the whole picture. So just knowing what you're working on helps. Ignition coils, on average, 6 to 10 amps of current flow, on average. You might see some as high as 12 amps. So is it safe to say for any ignition coil primary current ramp test that we could set our scope to a 20 amp setting and see it, and then scale down from there? I'm okay with that, or we can go the 10 amp if you want to. We'll go 20 just to back up what I just said. You see all that noise is kind of gone. It's still there, but it was just a low scale. Okay, now back to my book and the pictures. You look at the pictures on the book and you see a ramp that does this, and in the book you'll look at the scaling and it says 1.6 volts. You need to understand, well, that wouldn't be a good analogy because that's 16 amps, so you're not going to see anything that high. We just did one yesterday. It was 1.2 amps. That's 12 amps, because the setting that I'm using on the 20 amp setting on the low amp probe, this is universal, this is standard from what I've seen. All the Snap-on ones we have, all the Pico ones, all the aftermarket generic ones. The 20 amp setting on an amp probe is this: 100 millivolts equals 1 amp of current. So I want you guys to know, as you're looking at those pictures in my text, that a lot of the amperage patterns I chose to use was the 20 amp, but I left my scales on voltage for whatever reason. I guess I just felt like I wanted to do the math. You need to know that to know what those amperage levels are in some of the pictures. Questions? We good? So if you see 0.8 of a volt, how many amps is that? So if you see your scaling and the top of this is 0.8 on the scaling, what is the amperage in this on this tool? I know the camera's rolling. I can't do math either, especially on camera. So I'm with you guys. It would be 8 amps, okay? Because another way to write 100 would be 0.1 for those of you that don't know. 0.1 is 100. 0.1 would be 1 amp. 0.8 would be 8 amps. So are we good on that? Okay. So what's scaling? The point with all of that for this segment was, what do we want to pick? We covered that. We're going to be checking an ignition system, coil, primary current, somewhere between 6 and 10 amps. I like a 20 amp setting. That's fine. We may change that. What about a time base? There is no right way to do this. There's no right way to start. The scope that you're working on will dictate what you're going to do. For the Pico, remember the Pico, I can take a lot of data and have a lot of sample so I don't miss anything, and I can zoom in on it. Okay? The Veris, the Vantage Pro, the Snap-on stuff we have, I can not do that. I can zoom, but I zoom out on the buffer. So if I want detail and repetition, I need to take a small picture and then pause it and zoom out. On this one, I can take a large picture, pause it, and zoom in. Questions on that? Isn't that going to dictate what your time base is when you start? Here's a rule I follow. I have 3 coils. I want to see all 3. And I want to see repetition first. We'll worry about the detail later. I want to see repetition first. So if I want to see repetition, do we want a longer time base or a shorter time base? Longer. I want to see more time down here. Agree. I'm not sure what time. Let's change this to a half a second screen. This is 500 milliseconds. The screen is a half a second. We should have multiple firing events for an ignition system on here. If we start it and we see we don't have enough, we just change it. So that's it. We're ready to go, right? It's that simple. Any questions on the initial setup of an amperage pattern? You guys understand this is for anything. This could be for a fuel injector. This could be for a fuel pump. This could be for an ignition coil, a single system, a multiple system, whatever. No questions? All right, I'm going to start it. Whoops, that was dumb. Yeah, did you hear that? I'm lucky that didn't jump into my amp probe and cook my amp probe. Cook my scope. That would have been bad. Questions so far on what we're looking at? Let me get out of the way. Make that screen darken up a little bit. That's plenty of repetition. We know we have 3 coils firing. 1, 2, 3, 1, 2, 3. That's what we're looking at right now. I want to make sure that my sample rate's really low right now. I want to make sure that I'm getting enough detail here. Let me take a peek real quick. Yeah, it's pretty good detail even at 100 kilosamples. I'm still gonna take this up. 1 meg is the default. I just raised my sample rate just to make sure I'm not missing anything. If you're taking large captures, lots of repetition, you guys remember the discussion we had with sample rate? The longer sample you pick, the more the interval increases between samples, so we can lose detail. So that's why I just raised my sample rate, just to make sure we're not missing anything. Okay? I'm hoping this starts to misfire for us. It should. It was missing yesterday. I'm confident we didn't fix it. It's going to come back. While we're waiting, do we know which cylinder's what in here? We do not. So we want to have a way that we can look at all three in detail and know which one's which. And we can pull in a second channel to do that. There's something else we can do too. Initial view. As I see my repetition, they're all there, that's good. What about detail? If I go in further, this will give me my detail. Too much. I like that, but I don't like it. I like that for detail, but wait a minute. It's going away too fast, right? So what do we do here? Set a trigger, very good. So we set a trigger here. I'm gonna put it on repeat, and I'm going to put it anywhere from here up. Why don't I want to put it here? Is there a rising and falling edge in that oscillation? If you follow this over here, is there a falling edge over here? If I put it down into here, it's going to sometimes draw this side, and sometimes it'll draw this side, and it'll bounce back and forth. I'll show you. It should do it. That's rising. Let's do falling, sorry. Gotta love live events. Come on. I just can't get that one You guys understand what I'm talking about, right? Yeah. I could probably do it if I set this to a lower scale. I'm pretty confident that at some point it's going to draw that. Anyway, point is, stay out of the noise, okay? If there's multiple edges, a falling edge here, a falling edge here, sometimes it'll trigger there, sometimes it'll trigger there. We'll go back where we were. Trailing edge, leading edge. If I want to make this more stable, I can switch it to a leading edge, move it over, some delay. We have some dwell time differences, is maybe what you're seeing up here. Question, Adam. Why is one of them flatter at the top and then some of them are shorter? In short, there are some dwell time differences between these coils, and that may not be a problem. It just may be what the computer's doing, and we deal with it. This is a nice picture, though, of all three coils. That was the point of this. You need to understand, this is not one coil right here. What is it? It's all three that we're telling the scope to draw in the same location, so it makes for real nice comparison, doesn't it? Be nice to make this thing die on us again. Okay. While we're waiting, let's go back to 500 milliseconds. We'll turn our trigger off. We don't really need the trigger for this. You could leave it on if you wanted. I want to know which one's which up here now. How do we do that? Remember, we have 3 control wires. These 3 control wires that are on this coil, each control wire is for one coil pack. Can I grab one of those and use that to synchronize this? Answer is yes, I'll show it to you. I'm going to go to my number 1. I just put my black lead to a known good ground. I connected my BNC cable to the scope. Okay? Channel B, we'll go 20 volt as a default. It's there, but you see the waviness in that? My ground is bad. This one's a battery negative instead. This is stuff you'll learn as you use your scope. Pull that out of there for a sec so we can see it a little bit better. That was a pretty good guess, about a 0 to 4 volt square wave, wasn't it? Why would I know that on this Audi? I've never worked on one. All the coil overplug designs I've seen, all the designs I've seen like this, where the transistor is part of the coil, the base circuit is a 0 4 volt square wave. What's that?
Never seen a curveball?
I hate to say always and never, but not yet.
Just noise
Okay.
from the ground, or is it something you just have to
Noise in the middle that Kyle just mentioned, it's a good question. It's really not noise, it's actually there. It is noise from a standpoint of other systems. It's not the fault of the scope. It's reading something. If you notice the spikes in the red trace, let me throw a trigger in here.
They're right on.
In fact, what I'm going to do, that works. I was going to say I'll trigger off the red trace, but it's holding it pretty steady here. If you notice the spikes, it's moving a little bit. If you notice the spikes in between, they're lined up right with the other coils that are firing. So that spike would just simply be that. The other coil's firing and it's feeding back into this circuit. I could filter that if I wanted to get rid of that, but I don't mind leaving it there. I want to keep my detail, so I don't want to filter it. What does this tell us? I'm changing my trigger. What does this tell me about these coils? Let's pause this right there. And Josh, can you shut that off for me, please? Or no, we should probably leave it run in case we can make it act up.
Because they're all firing.
What does this tell me though about this coil?
Number one.
Let's run it live. Is it any coincidence that the turn on of the red trace is the beginning of the current, and the turn off of the red trace is the end of the current flow? So they're timed exactly with that. Let's drop the time base and look a little bit less of this. Can you see it? You see it? So what's this red trace tell me about that?
There it is.
That's awesome, we caught it live. I'm glad we didn't shut that off. What did the red trace tell me about that coil that was there a second ago? We should pause and see if I caught that. Did I catch the moment? It went through the buffer too fast. It's okay. All right. I missed a window to teach you something. I think you guys all understand though, if I know where my red trace is, I know that that's my number one coil, right? And so if I know the firing order, then I can plug in what my other coils are. This is a waste spark though. Let's keep that in mind, that when number one fires, number one cylinder, number 6 is firing 2, and then when number 6 fires, number 1's firing 2. So this is only 360 of the crank. That's not 720. 720 would be 2 of these. From here to here would be 720. Okay? You guys understand that? So if I put a 720 mark in here, we'll go right on the around the trailing edge of that. This is not going to be, doesn't have to be exact. There's 720, the crank. How many cylinders do we have in this car? It's a 6-cylinder engine. So we have 1, 2, if we count that one, 1, 2, 3, 4, 5, 6. Okay? 3 coils. We fire each of those coils twice per 720. One time, number 1's on top dead center compression. The other time, number 6 is on top dead center compression. Do we know which one's which here? Do we know if this is 1 or 6? We do not. We don't. But for our purposes here, it doesn't matter. What do we see up here? 1 and 6, the current flow disappeared. Okay? Let me back up for a second. Is there a way to figure out if this was working properly and we wanted to know which one was exact? There is a way to bring in another channel. We can pull in a plug wire and look at the high-low firing events of a plug wire. We could do that. Another one would be if we knew the firing order. Yeah, it's not important for this.
14365.
The problem is, do I count it this way? Do I go 6, 2, 5, 1, 4, 3, or do I go 1, 4, 3, 6, 2, 5? You guys with me on that question mark guy? Does it matter as far as identifying which coil is not firing for us, even if we plug in our firing order wrong? So how would we know exactly where? We could pull a third channel in, grab a secondary. That just started firing again. That was cool. It's too late. It's too late. It's too late. That buffer, it's 30. It's what this is, Kyle, is 32 million samples. So it has a 32 million sample rolling buffer, and my sample rate is 1 mega samples per screen. So if you do the math, this is a 500 millisecond screen. How fast are we going to fill the buffer? Quick. Somebody good with math? Is it like 16 seconds? We probably could have caught it. If 500 milliseconds is 1 million samples, how fast will we fill a 32 million sample buffer? That's the question. Who cares about the number? It's pretty fast. Anyway. 6? I heard it. Did it skip the coil ramp for a second?
Get ready to.
Okay, I don't care about this. Let's get rid of that. Get rid of the cursors too, my 720 cursors. Everybody okay? We're not like fume-wise in here. We might want to put that fan up in the door.
When that car runs that fan on, I don't hear you.
What's that?
I said when that fan comes on, I can't hear you.
I'd rather you maybe not hear me very well than fall over and die from carbon monoxide poisoning. Is everybody okay? All right. Huh? Nah. He's not even going to address that. All right, let's talk about what we saw, and hopefully this will happen again while we're watching it. I'll drop my time base down. That works. Okay, when that thing stopped firing, did you notice that we had our computer's control still? Did you guys see that? We still had the red square wave, didn't we? What did we lose?
Spark.
We lost spark and we lost the ramp on the primary side. So we're really done at this point. The coil is, well, no, go ahead.
I actually swore that's what I thought.
Oh.
Does that mean the coil is not working?
Yes, at this point, the reason that we're done is this system is all one assembly. What we don't know right now is, was it the driver that failed in this unit, or was it the primary winding? If there's no current flow, which there was, would you agree with me that that is an open circuit? No current flow is an open. We're not worried about a short to ground. No current flow is an open. So either the primary winding in the coil is, when it's getting hot, it's opening up. There's a little break in it, temperature-wise. which can happen. It can work perfectly fine as long as it's together, and then at that moment it opens up, we lose current flow. Or it could be the driver itself in the in the module, igniter, power stage, whatever they call it. Curious on the diagram what they call it. They just call it an ignition coil. That's a Mitchell diagram, but it could be the driver that's malfunctioned. If this was, guys, listen, this is important. Some of these designs that look like this, some of you are probably thinking, and we were yesterday, let's take the number 1 coil and move it over to the number 2, move the number 2 to the number 1, and then we'll be able to tell if it's the driver or the coil. Make sense? Problem is we can't. Here's why we can't. Open.
Open sesame.
This is why we can't. Even though the coils are unbolted at the top, do you see what's underneath? I can't move the coils, not without cutting the coil. So if this is coil number 1, right? Yeah, I'd have to cut these 2 wires and then cut these 2 and then swap the coils and then re-solder them.
Yeah.
That would be cool for maybe doing it here, but it's not practical. And when you buy this unit, what are you buying? The whole thing. Are we done? How's the computer? What about the rest of my wiring? Do we have to worry about the power and ground to the coil? We do if it was a single coil system. We don't because the other 2 are shared. We're done. It needs an ignition coil.
What thing?
So imagine if that coil, Adam, let's address your question to start with. Imagine if that coil lived underneath the intake manifold. How quick was that? We could identify that problem. That's pretty cool. Not have to pull the intake off, not have to try a set of plugs, right? I really want to see that die again. Did you notice the red square wave, the red turn on signal? It actually, instead of looking like it does now, which is a slight arc, did you notice that it went to a square? It just has to do with current flow through the base of the transistor. It potentially could tell us that that transistor is what's failing here, and that's what it looks like. I'm not totally sure that we can say that with 100% confidence that when we see a straight up square wave on the base of one of these that the transistors failed. I don't know enough about base circuit current to answer that, but that's what it's suggesting to me. The straight square wave is suggesting it's not an open primary, but it's a driver that's opened up and there's no flow in the base. My guess, and not sure, is if it was an open primary, we would still see kind of a ramp here, maybe, if there was flow through the base. Open primary, but it could be the ramp itself, the high current flow through the collector and emitter is what's causing the base to look like that. And so from that standpoint, whether the transistor's open or the coil's open, we would see that pattern. Not sure if you guys followed that, but maybe.
So if that was a driver that was in the computer that was failing, then you would have it die and then you'd have no stop.
In this case, if it was the driver in the computer that was failing, what we would have,
Lose all 3.
we would have lost, remember there's 3 different drivers. We would have lost the red trace and the blue trace. So that was where seeing that red trace square wave still being there, the same time the ramp was missing, says the computer driver's fine. The computer driver, remember there's 2 drivers here. We have a coil, a transistor driver here, and this is inside the PCM. There is another transistor inside of here. That transistor is controlling that transistor, so which driver are we talking about is important in this discussion. When we lost our current pattern, we want to see ramps, but when we lost it, we still had our square wave, which says what? That driver's good. It doesn't tell us if this was bad or this was bad. I can't tell you based on looking at that. I'm not good enough at the pattern. I think the ramp here is affected by the ramp here. So you can't look at that square and say open coil, open driver. We don't know. We need that fan set up in that door. Adam, please set that up.
Way to go, man.
Well, the tips are only that big.
I know. Just snap it a couple times. Let's see if we can make this act up again. Shut it off. Wait 5 seconds, then restart it. Go ahead and restart it. I just want to see this. I want to see this fail one more time. I tapped on the transistor part. Okay. Are we comfortable with this? You guys understand that my PCM driver, the control for the coils on this design is good. We good? So it's getting an ignition coil assembly. Should we worry about plugs and wires on this? For this particular failure, I'm going to say no. If we have a plug or wire problem, too high of resistance in a plug or wire, we'll see a big tail on the end of one of these ramps. We did, but that was on a different tool. We could simulate, just to see if we can see it, we could simulate an open plug wire. I can open a plug wire. We have to change the coil anyway, so what if we damage it, right? Let me open a plug wire and let's see what the tail, I'll do it on not the number 1 or 6. Here's the debate here. Do we sell the customer plugs, wires, and a coil assembly, or do we just sell them the coil assembly? Based on mileage and that these are original plug wires, what's the mileage on the car? 140,000. I wouldn't even hesitate. If I'm in the field, it's getting plugs, it's getting wires, it's getting a coil assembly. But I think from a training standpoint, or if this is your car, it wouldn't be a bad idea for us to take a look at some tails on the...
Why isn't it showing the tails that we see?
I can't answer that. I'm not sure. Shut that off real quick. Okay, go ahead, start it up. Hang on. Come on. Here, can I get one of you guys to pause this for me whenever I was going to set up a trigger, but it'd be easier just come over here and you need to, or actually do this here. All you're going to do, keep your hand away. I want to pull this away momentarily, like that.
Yeah.
Okay.
Tell me when.
Go ahead. Okay. That should work. Shut that off, Josh. Okay, guys, look. When this coil failed, when this driver failed, one of the things we have to consider is, did we have an open secondary? Do we have an open plug or wire that caused it to fail? You guys understand what I'm saying right now? Do you see the tail on this? Do you see the tail on that? No coincidence. that coil is that coil. If I zoom in on that a little bit, see it with a little bit more detail. When you see a large tail like that on the end of a primary current ramp pattern, it suggests an open in the secondary, meaning the coil fired and had nowhere to go. Where does the coil fire? Does it fire here or does it fire here? Let me restate that. Where does spark occur? Does it occur here or does it occur here? Spark occurs at the end of the ramp. We turn the coil on, we energize it, we give it a certain amount of dwell time, then we turn it off here. That's where our spark occurs. Everybody with me? So why would we have a tail? Why would you get a tail like that at the end of the ramp? What caused that? That secondary has nowhere to go. So what's it doing to the coil? It's taking it and it's shaking it, ringing it. Are we seeing that back feeding back into the primary? That's what you're looking at. So my point with that was when we were losing our 1-4 coil, which we saw, could that coil have failed from an open plug wire on the 1-4 cylinder? The answer is yes. But when we had the ramp and it was firing normally, do we see a tail? Actually, look at it now. This is the 1-4. Do we see a tail on that? Do we see a big tail on this? That needs to stay on. It's still bad up here, yeah. Sorry.
I would say it smells good back here.
It's not up here. Tail? No tail. What killed this coil or transistor? Debating on that. What killed it? Was it an open secondary or not? No. So here's the point. If this is your car, if this is my car, I am putting a coil only in this car. I'm not worried about the plugs and wires. That's it. Mileage, the numbering, original plug wire says let's do them all, but you understand the difference between saving yourself some money in this scenario or another scenario that would be, I used to get this all the time. Cars would come in and Ed, you would probably remember this with the GMs, the older GMs. The car would come in with a misfire. So the guy would do crank sensor, module, all 3 coils, plugs, and wires. Well, of course you're going to fix the misfire. You just changed all the parts in the ignition system. But can you tell me exactly which one failed? I think is really important. Not I think, I know it's really important. That's what we're doing here. Coil current ramping. That was a pretty cool picture. See if we can catch it one more time for Ed to see it. We got that plug wire back in, right? Go ahead, start that. Yeah. Yep, start that back up one last time and then we'll go to shop. Go ahead. Ed, red trace for the number, wait. The red trace for the number 1-4 or 1-6 coil that's what's controlling the coil, okay? So there's 3 coils. This would be 1-6 and 1-6. So watch these guys. I'm gonna tap on it again. See if we can make it fail. On the okay, kill it. Oh. Questions? Everybody good on what we saw there? Bad coil, bad transistor is what it looks like, not the coil itself. It's the transistor. If this was a unit, again, that we could swap the coils, it's not. It looks like it is. You can't. It's all one assembly. Ed, here's your picture of the underside of it. Can't do it. If this was, we could swap the number 1 with the number 2 and then see if it stays in the same location. You guys understand that, right? If it moves with the coil, what is it? Bad coil. If it stays in the same location, what is it? Not wiring, transistor. This is looking absolutely like a transistor issue. It doesn't matter, we're changing the whole piece, right?
Yeah.
Okay, cool.